All right, so in this section 6.4, we're going to be solving some more equations, but this time they involve the inverse. So we want to recall back to our inverse, we only want to use specific quadrants, right? So remember that for sine and its reciprocal, we're only dealing with quadrants 1 and 4 because in the first quadrant, sine is positive, and in the fourth quadrant, sine is negative. Right, with cosine and it is reciprocal secant, we're going to only be dealing with quadrant 1 and 2. And again, quadrant 1 is where it's positive, quadrant 2 is where it's negative. And then tangent's weird. So tangent's quadrant 1 and 4. Okay, and that has to do back to when we graphed tangent. We're only dealing with those two quadrants. And then cotangent is quadrant 1 and 2. So quadrant 1 is where it's positive, quadrant 2 is where it is negative. Okay. Everything else, notice that the one quadrant that is not shown is quadrant number 3. So I have a couple of steps, so to speak. They're kind of generic steps of how to solve it in terms of y. This type of problem does not produce an actual number. So no number in answer, because there are two variables. So we're not going to get an answer like a 1/2 or a √3/2. So the first thing you're going to see is you want to isolate our trig function, apply the inverse trig function to both sides, and solve for x. That's essentially what we're going to do. So what does that look like? All right, so here we go. Example number 1 on these types of problems. So I say 6y is equal to 1/2 the secant of x, and we are going to solve for x on this problem. Because if we solve for y, it'd be super easy. Just divide everything by 6. Okay, so we want to isolate our trig, so we want to isolate the secant of x. So I'm going to go ahead and I'm going to multiply this side by 2, and I'll multiply this side by 2. So this will become 12y is equal to the secant of x. And so when we apply the inverse, this is essentially what you're doing. I'm going to rewrite this a little bit bigger, a little bit more space, I should say. So secant of x. So what we're doing is we're applying the inverse. So I'm having my inverse right there, and then I'll apply it on the other side of the equation. Because again, inverse and the regular equation will cancel each other. They cancel each other out. They undo. It's the undo of the property. So that being said, this inverse of secant of 12y is equal to x. And then that's it. This is our final answer. So notice that when I said it doesn't have a number in it, it's because we don't know what y is. So I can't take this problem any further. All right, let's try a second one. What about this one? So again, solve for x. So y is equal to tangent of 2x minus 1. Well, on this problem, we can already see that the trig is by itself. There's no number on the outside of the tangent. So I'm going to apply the inverse to both sides. So inverse of tangent. So this will become the inverse of tangent of y is equal to, and again, these cross off, 2x minus 1. And we would solve it just like we would solve normally. We're going to add 1 to both sides. So inverse of tangent of y plus 1 is equal to 2x. And again, make sure that you do use parentheses. We don't want that plus 1 to be with the y. We're going to divide by 2. So tangent, the inverse of tangent plus 1 all over 2. And that is our answer, is equal to x. All right. So again, we don't know what y is, so we can't take this any further. So let's try one more. Again, let's solve for x. So solve for x. And y is equal to 3 cotangent of 5x. So pause the video, try this problem on your own, and see if you get the same answer. All right, coming back from the pause video, the first thing we should have done is divide everything by 3. So this will become y over 3 is equal to cotangent of 5x. And then we're going to apply the inverse. So inverse of the cotangent to both sides. Bring it up over here. So the inverse of the cotangent of y divided by 3 is equal to 5x. Divide by 5. And we have this answer as our x. Now we don't have to divide by 5. We could have multiplied by the reciprocal. So I could have said this 1/5 cotangent of the inverse of y over 3. This is perfectly fine. So both answers are the same. So either one. Okay. So these are pretty straightforward problems. Now what happens if we actually know what the y is, right? So let's try a different problem. Okay, so again, solving inverse trig. So if the inverse trig function appears in an equation, what we want to do is we want to isolate it. Okay, so this one already has inverse in it. Then we're going to solve for the variable and apply the inverse of the inverse trig function to both sides, basically what we were doing, and then solve for whichever variable, and we want to sketch a right triangle where appropriate to help us solve if we need it, right? Sometimes we need it, sometimes we don't. Okay, so that is our steps. These will most likely produce an actual number for us. So we're going to get something, and it might be on our unit circle, it might not be on our unit circle. So let's try our first problem on this one. So example number 1, we are going to solve for an exact solution to this arc cosine y minus pi over 3 is equal to pi over 6. Okay, so the first thing we're going to do, we're going to isolate our inverse trig. Our inverse trig is on the left side already, so it's already isolated. So I'm going to apply the inverse of arc cosine, which is just cosine, so I'll apply it to both sides, so cosine. So over here, these two will cancel out, leaving you with y minus pi over 3 is equal to the cosine of pi 6. All right, at this time, we can simplify things a little bit more. I actually know what the cosine of pi over 6 is. That is on my unit circle. So I'm going to replace pi over 6, the cosine, with a root 3 over 2. That's all I can do. I want to isolate for y, so I'm going to add pi over 3 to the other side. Pi over 3. And that's it. That's all I can do to this problem. There's no need to set up a triangle in order to solve some more. Okay, let's try another one. So we'll call this number 2, do it in blue. So again, solve for exact solutions. And this time it says the arc of tangent of x is equal to the arc cosine of 5 over 13. Now this one is a little bit weirder because what do you notice is we actually have two inverse. So which one do we actually want to solve? We want to solve the left-hand side because that has our variable. Okay, so I'm going to go ahead and I'm going to apply, because it's already by itself, tangent to both sides. So tangent, again, these are going to cancel each other off, leaving you with x is equal to tangent of the arc cosine of 5 over 13. Now this should be familiar to our first video where we didn't have an x is equal to, we just had an expression. So what did we do? We said let theta equal the arc cosine of 5 over 13. So in reality, what we have is we have x is equal to tangent of theta. Let me write theta in green, color coordinated. So essentially what I need to do is figure out what this is. All right, what do I know about tangent? I know it's made up of y over x. What I know about cosine is I know that it is x over r. So I would apply, let's apply the inverse to both sides. So cosine of both sides. So this is going to be the cosine of theta is equal to 5 over 13. So this is where the triangle can come in handy if you want to. Not a big deal. I'm just going to say 5 squared plus y squared is equal to 13 squared. So 25 plus y squared is equal to 169. Subtract 25. I get 144. Y is equal to plus or minus 12. Now we want to pay attention. Cosine's positive. So if it's positive, I know I'm going to be dealing with quadrant number 1. And where is tangent also positive? Quadrant number 1. So I know where I'm at. I'm in quadrant number 1. So I'm going to say that my answer is x is equal to whatever tangent of theta is. So tangent of theta is my y, which is a positive 12, over my x, which is 5. So notice that I actually did get an actual solution on this one. Okay, let's try another one that's kind of similar to this. So we'll call this example 3. So example number 3. So again, solve for exact solutions. All right, so this time let's write it like this. Let's say the secant, oops, let me rewrite this better. So the secant inverse of x, is equal to the inverse of tangent of 4/3. So again, very similar to that last problem. So I'm going to go ahead, I'm going to apply the inverse to both sides, so secant and secant. So this will just become x, and this will become the secant of the inverse of tangent of 4/3. Again, I'm going to write a quick little let statement. So let's say theta is equal to the inverse of tangent of 4/3. So this is really the secant of theta. What do I know about the secant of theta? That is r over x. So now dealing with this guy over here, I'm going to apply the inverse. So this becomes the tangent of theta is equal to 4/3. Again, this is positive. So we are dealing with quadrant number 1, which means this is also in quadrant number 1. Y, so 4 squared plus 3 squared is equal to x squared. 16 plus 9 is 25. Oops, sorry, not x squared. That should be r squared. Change that. So r is only positive, so that's a positive 5. So this should just be 5 over 3 is equal to x. Because again, we have an expression, or we used to have an expression, now we have an equation. Okay, in part 2, we are going to, we're going to see some problems that actually have to use the identity to help solve.